Welcome back. We're going to determine whether this following molecule is aromatic or not. Now, unlike a compound that contains only carbon and hydrogen, like we saw in the previous case, when you have nitrogen, you have to take the minor nuances into account. Okay, and I mentioned the idea of Lewis structures, right? Now, just like how I told you all in Chem 330, carbon must have 4 bonds, right? No matter what the compound is, carbon must have 4 bonds. Now, nitrogen must have 3 bonds. Now, if you remember your Gen Chem knowledge, nitrogen has a lone pair of electrons, okay? Now, for the purpose of easier understanding here, without going into way too much detail, the lone pair of electron is equal to this one. Say this is your double bond, okay? This is your pi bond. This lone pair of electron is equal to the bond on a double bond, okay? This is equal to a pi bond, okay? With that in mind, now I am going to put lone pair of electrons in this molecule. You should be very careful where you put it and the precise location of it, all right? If you look at this molecule, in all the cases, nitrogen only has 3 bonds, which is a good thing, because otherwise we're violating the idea of nitrogen cannot have more than 3 bonds. But if your double bond is inside the ring attached to the nitrogen, the lone pair is outside. Whereas when you have a nitrogen that's attached to all single bonds, the lone pair is inside. This is very important because you cannot put the lone pair here if the nitrogen contains a double bond. Why? It has something to do with other things, but we don't want to get into that for the purpose of delocalizing this electron, right? Now, like I said, moving electrons in this particular problem, or one more that we're going to look in the next video, I want to show 2 different versions of it so you can understand it better. Is first you need to know where you put the lone pair. Again, we got to put it outside. When it is outside, it cannot be used to move electrons around. Only when it is inside, it can be moved, right? All right, I'm going to show this in different color. Now, as I said, moving electrons when it comes to lone pairs of nitrogen is not as straightforward. It's still simple, but it's not as simple as when we did carbon and hydrogens, okay? So, as I said, this is equal to a bond, okay? This is equal to a bond. So, if I move this here, okay, I cannot just keep moving it forever, okay? I gotta stop here. And what it does is, in chemistry, when an element, okay, when an element loses electrons, okay, it gets a positive charge. And when an element, whether it gains 1 electron or multiple electron, it doesn't matter. When it gains electron, it gets a negative charge. Again, this relates back to your general chemistry, which again was related to this concept here, right? So this nitrogen has moved this electron here, which becomes a bond now because, like I said, this is essentially a double bond. So this is moved here, this is moved into the nitrogen. So what we need to do now is, let's redraw everything the way it looks like, okay? I'm just going to redraw the molecule and leave the lone pair that are outside undisturbed because they cannot involve themselves in resonance. And I'm going to draw this, again, draw everything the way they look like. We didn't disturb any of these guys so they can remain where they are. Now we have moved this lone pair of electron here, so that becomes a bond. But what has happened here is this nitrogen has lost its pair of electrons. So this gets a positive charge. This has moved here as another pair of electron, okay? So this becomes negative. You see, what is this pair of electron lost here is here. But now we can put it inside because this double bond is moved in as the electron. It's very important you notice the subtle changes we have done to this molecule compared to this one, right? Now we can continue our resonance into, this is the first resonance structure, okay? Keep in mind, this is slightly different than a compound containing just pure carbon and hydrogens, okay? So now what we can do is, now when you move the negative charge, that means you're moving both the electrons, all right? So this can now move here, and this can now move here, okay? Right? So what does that do then? So let's go ahead and draw everything. Again, first draw the molecule, okay? So this still has the positive charge here. We are not disturbing that yet. We'll eventually get back to it. So let's say this hydrogen's here, and this is important that we stop here and take a look at what has just happened. Okay, this bond, because we are moving a negative charge, the negative charge is now here. Okay, this bond has now come in as a lone pair of electrons, okay, as a negative charge. So let me actually get rid of the little oval, okay. This cannot just go like it normally used to be, because when you deal with nitrogens, you're dealing with positives and negatives. So everybody is still there. Now this bond is become here. This has become a bond, but because we're starting with a negative, we must finish with a negative, and the lone pair of electron here is now here. Keep in mind, this bond is also made up of 2 electrons. It's just a basic understanding that a bond is made up of 2 electrons. This is a second resonance structure. Now what we can do, well, we can continue moving this on. So this negative charge is here now, right? So we can now move this over here and this over here, okay? Right? Because this is outside, we cannot use this, okay? That means this now is moved here. It's moved into the carbon. It doesn't move as a bond. So if we redraw it, this concept, you may have to watch the video multiple times to get the idea of what has happened, okay? It's not as straightforward as what we did with. You see that the positive charge is exactly where it is. It's only the negative charge that's being continued to move around. Unlike, we don't just move the bond, we move the charge, okay, if that makes any sense. So now we've moved the negative charge as a bond here, but then this bond must move here. So that negative charge is now here, and the lone pair of electron moves here. So you can continue to do that, and then this can now move here. This can move into this carbon. It doesn't move into the next carbon as a double bond. Instead, it moves in as, so if you draw the next resonance structure, again, I haven't even disturbed this positive charge. It's in the same exact spot like where it's been for decades. You know, it's not moved anywhere. And these 2 electrons outside. So there's a lot of minor information that's mentioned in this video. You may have to play it from the start every time, unless you got like the first 10 minutes, then first 5 minutes, then you move to. So now this is moved here as a bond, and this has become a negative charge on the electrons here. This is the, so you see in this case, I have taken my time to show multiple resonance structures over the other ones, because the one in the previous video is much, much simple, okay, compared to this. This takes a little bit of understanding, but this is how you do the resonance structures, okay? Now stay tuned. This is all there is for this particular compound, okay? Now, I'm going to do it for another compound, and then you can watch both videos, and if you have questions at that point, you can ask me during class, all right? So stay tuned for the second compound.